and then when I drop it down, it goes back down to idle. Now, I did set an angle mode for this. See, it still yaws and everything like it's supposed to. And it goes to, you know, aileron. So, but it just feels like it's RPMing like really too hard. Well, now when I set an angle mode, again, I could only use the other knob because it doesn't recognize my switches. And I put it to angle mode. And it goes like that. And then if I barely touch the throttle, had to disarm it. Okay. So this has been, battery cable's warm too. I already burned out one of these capacitors. If I let it go too high, then it just pops the capacitor. So I don't know if it's something in beta flight or what. None of these switches work. I don't know what I'm doing wrong. I haven't used Fly Sky stuff before. I kind of lost all my other stuff, you know, a long time ago. Yes, I'm experimenting with a Dyson style nacelle. Don't tell anyone. This should produce enough thrust to lift it. If it doesn't, I'm going to shrink the nacelle, and then I'm probably going to go direct with the tube. But it's just a prototype. It's just, I'm trying something new. But the problem is this. It's just you arm it with the only switches you can arm it with. Take off the angle mode. And then just... It sounds like one's spinning down and like the other three are spinning up or something like that. Not even touching it. Throttle's still in the same spot. So, yeah. That's what's going on. And this isn't producing any lift yet because I have a hole to plug down there. But, I don't know. I'm not sure what to, how else to explain it. I've got my RX hooked up like that. Yes, my solder jobs look like they came out of a soft serve machine. Kind of just see it melted off that again. It melted off that cover for the leg. It gets this real. Look at that. I think I popped this one too. So I don't know if it's something in beta flight or the ESC or something. I don't know. What do you think? This is getting too hot. It's over revving. It's revving on its own. I don't know what I'm doing wrong. These are 3200 kilovolt 4S. This is just a 7200 milliamp ADC. I know that doesn't matter as far as the C rating goes, because I'm going to max out this battery anyway. But, and you know, and I'm running everything through servo and iBus. I don't honestly know what to do at this point, so I'm just kind of hoping that you have some suggestions. Okay, I figured out the easiest way is just to show you this. Yeah, this is part of my nacelle design. It works, but I'm having problems with the motors. They're over RPMing. They're
Okay, looks like a bit of a mess because I'm still calibrating ESCs and getting servos mounted so that I can control these. But I wanted to test the ESCs, so this is what we have so far. This is a different design. It is working rather well. I don't know if I trust these ESCs, but I went cheap just for the purpose of prototyping. So Okay. I have no yaw control yet, so I just wanted to test it. Everything seems to be working. Alright, so I'm doing a test on this ESC. I haven't done the test on the rest of these ESCs yet, but I had to try this to see what's going on. Can anyone tell me why this EDF is making this noise? Can't spool it up and it starts making that noise. I don't know if it's the ESC or the motor. The wiring is hinky, I know, but it's just because I was testing. I'm waiting for my bullet connectors, but everything's solid on the wiring. I don't know. It's making a weird noise. I can spool it all the way up, and that's it. Okay, I don't have a lot of yaw control. I'm going to incorporate that. I've got a push on the left that's higher than the right, so we're going to test it out. Alright, hold on. I think I killed my battery. But at least we know the thrust forward. We know that that's working. So hold on, let's see how far it goes. Alright. Okay, I don't have a lot of yaw control. I'm going to incorporate that. I've got a push on the left that's higher than the right, so... I think that's powerful enough since I'm using 3 of them. Oh, this is going to be good. Alright, so I'm only testing one motor right now. I may have to adjust the trim on these a little bit. Not the other way. Hold on a second. There, that kind of trimmed out. Okay. I'm not going to go full throttle. I'm going to kind of hold up this end. I'm only running one motor for a lift test. And I'm only supporting this side. Woo, hold on. Slow down. That's not even at full throttle. It's about 40%. And that is with an 80C battery, but they'll be running with 120C batteries, and I still have my aileron control right here. And if you look at over here, I still have my yaw control with the front thruster, which will go here, and then that'll complete the circuit. I have a motor installed here, but I haven't done anything with it. I'm just trying to see how far. I get about close to half throttle on one motor. So far, so good. Alright, we're testing the lighting right now. Still waiting for 2 motors to arrive. But it's starting to look pretty good. Yeah. Good, good, good. It's controlled by an Arduino board, not underneath the craft. So you can get a closer look that way. It's actually pretty cool. It's hard to see that one because it's back there. But it's gonna look good. Okay, so what we're doing right now is we're doing a test with 2 motors. I'm gonna hold the front just to see the stability of the gyro and pray.
Stabilizing itself. Okay, well, a couple times I had to catch it, but it's stabilizing. The gyro's stabilizing it. There's a lot of ground effect from the thrust going out. We don't have to sweep here now, so that's good. Mission completed. Okay, so what we're doing right now is we're doing a test with 2 motors. I'm going to hold the. It's almost there. So what I've done now, as opposed to these nacelles, the way that they're bent down, I decided to go with a more angular approach here, as you can see, to eliminate weight and to stop the vacuum that I was getting from underneath the craft from it being vertical. So we're gonna test how it reacts. See as I go backwards, it goes down. So I think this new design will work perfectly for all three nacelles, and then this will be the orientation right here on all three. So what I've done now, as opposed to these nacelles, the way that they're bent down, I decided to go with a more... We're going to try this again. I'm going to hold it off the ground and see where the instability is, and then I may end up putting on the gyroscope, but we'll see. Well, that hot glue didn't hold. All right, what are we doing now? Well, we have redesigned the drone. The way it's going to look is going to be a mystery. I have switched out the 4S motors with the 6S. I'm using a SpeedyBee wing, so I can use VTOL. I have adapted it with a APD 500 continuous current amp power distribution board with 2 inputs. This is a nice distribution board because EDFs draw so much power. You want to be able to not overheat, which was one of my main issues before. So I know it looks like a mess right now, but what will it look like when it's finished? All right, so here's the situation. Since I'm using 70mm EDFs, I went with a power distribution board right here that can handle 500 amps of constant current. Never mind my soft serve soldering job. Everything's working. So when I boot this up, like I have 1 motor set here. There'll be 4 total, obviously, but this is just for the setup. I was going through iNav and doing some stuff. So hold that. When I hook up the battery, this is what happens. Okay. Okay. So I hooked up a 4-cell battery. It's okay. But here's the thing. This should give me a battery indicator right here. That flashing light should... My hands are in the way. Should give me a battery status indicator, but it's not. Okay. Now the only way I have this hooked up is I have the SpeedyBee's 405 wing is the crossfire connector is actually being used for the regular serial bus controller. Okay, so it's S bus is selected, and then under that is I bus. That's the only way I can get any kind of response on iNav through the controller. The throttle, the yaw, everything works. But, and I've also set a pre-arming switch, so I can set a pre-arming switch, pre-armed angle switch. You can hear it beep when I put the angle switch on. This is so I don't kill it once I actually build the thing. But when I go to arm it, that's not coming from the motors. That's coming from the beeper. And it won't arm the motors at all. See? Nothing. I can turn that off, turn off pre-arm, turn off angle mode. So the question is why? What setting in iNav am I missing? Or do I need some kind of telemetry from here, this board, to the SpeedyBee? Because I've bypassed the power distribution board on the SpeedyBee by just running the, a 12 volt in the ground to it from the other power distribution board, effectively just bypassing it. So the question is the fact that this is hooked up solely through these signal wires only to motor 1, motor 2, motor 3, motor 4. Because in iNav, I can go into iNav and I can go into outputs and I can spool these motors up through iNav. So the controller is functioning, and I've made sure that the throttle was at 1,000, like right at the dead bottom. It's actually a little bit below. So there isn't any throttle applied when I arm it. So I'll go pre-arm, arm again, and that beeper's going off. Won't arm the engine. So I guess the question is, why is it doing that? I'm not really, great with iNav. This is still obviously a project that's right in the middle of being done. But, so why is it doing that? Why am I not getting a battery indicator? I assume it's because the battery's not going straight to the ESC pad right here. I'm just running a straight 12 volt line into it. And this can handle all the way up to 36 volts. So that's not, a big deal. But is it because I don't have an ESC on that PD for the F405? Or is there is a telemetry line here that can go out from this PDB? And if it does, if that's the issue, where do I connect it to on the SpeedyBee? Is there a telemetry input from here? Because the SpeedyBee's power distribution board has pins, so as the stacks, someone sandwiched together, it's actually, there's no labels on those pins because it assumes you're going to use that PDB for the stack. But since I'm not using that PDB for the stack, I'm using it just to power the controller by running 12 volts from this PDB to this PDB. I'm not getting a battery level indicator from that battery. It's acting like it's hooked up to the computer, which is weird. But through iNav, I have all the controls. You can see when you go to the screen, you can see that all of my stuff's centered out at 1500 and the throttle's down at 1000 and the switches are in their ranges. And in the modes switches, I did set a pre-arm, like I mentioned, and an angle mode and an arming switch, since I have 10 channels on this thing. Now, what could be causing it to do this when I go to arm the drone? What in iNav should I be looking at? Because I'm kind of lost at this point. I'm kind of new at iNav. So what exactly is the issue here? Because I can spool, like I said, in iNav, I can spool the motors up, no problem, through the outputs portion of it. So I know it's communicating. So what am I doing wrong? This should be a battery indicator light, probably, like I said, because I don't have an ESC directly connected to that pad.
It's just getting a straight 12 volts. And the ESC here is pushing all the EDFs. I have to because it's 340 amps constant current. Once if it at full throttle, and this can handle 500. That's why I did it, because I had heating issues. And since I have 2 battery input terminals, I can put 2 batteries on and lower the current load on each battery, which will also reduce heat. So in the wires and in the connectors and stuff. Because I had the Speedy Bean F405 V3, which was just the regular one, not the wing. And I kept blowing caps on them because these were drawing way too much current. So that's why I went to this board. So the reason why I got this board is because I wanted to use the VTOL function, because I have plans for this whole mess. So what's causing it? What am I missing? Any suggestions from anyone would be totally helpful. One, pre-arm switch works. This angle switch sounds like it works. See? But arm it, nothing. So any help would be appreciated. Thank you. Okay, experimental drone update. I figured out why it wasn't arming, and figured that part out at almost the sacrifice of a nipple, because these 6S motors are no joke. So, but it's working. I'm gonna get everything else constructed, then get everything set up, and then I definitely need to drop the gains because we are dealing with EDFs. And I say drop the gains because it sounds like something I'm supposed to do. I'm not real experienced with this stuff, but I do have a Speedy Bee F405 wing working with an ADP 500 amp power distribution board. It's working. Cross your fingers, we're almost there. All right, here we are at the setup so far. We're doing a test. I've done built the port aft thruster mount of this contraption. So here we go. I'm gonna run just a spool up to make sure everything's working. Arming. Woo. So she's working. More stuff to complete, and then she's finished. So on that design, we have exactly 3 more engine sections to build, and then we'll have a view of the overall internals of the system. ×4 EDF 70mm 6S. And we're back again with the monster. I am running a Speedy Bee 405 wing. We're just going to arm it real quick. It does require 6S batteries, which will sit here and here. This is just a 4S, just a test. I still have a lot of programming in iNav. Angle mode on, and arm. All servo controlled. For pitch and rotation, when in VTOL mode. Obviously not going to do too much on a 4S, but I'm waiting for my 6Ss to get here, and I can plug them into both of my 500 amp board. Alright everyone, we're back again with the monster, and I am trying my best in iNav to get this thing to work properly. So I don't know what is going on in iNav. I've got drone mode, obviously. That works fine. I can transition. First 3 motors transition. This servo's not working, not sure why. But if you look, see, I'm using the same rotating servos as my ailerons. and then it'll be a fixed wing. But the problem is on iNav, you can see one's coming from the top down and the bottom up, and then the other one on the pitch is moving up, and it wants to push the second one, which is back here, down if I can get it to turn on. So I need your help. Can't figure it out. It's starting to drive me crazy. I don't know iNav. Any help would be appreciated. Let's get this monster flying, huh? Okay, so this is what we're gonna do. Now, I have been basically working on a different type of drone. The specifics of it, I really won't get into, just because there's a lot to it. But let me explain the concept. The concept behind this is that these 4 engines, all 4 engines, can transition forward when the fixed wing is on here, and I can use these 2 as aileron control as well once transitioned. The rear can stay either fixed when it's in transition mode forward, or the front can. One of them will be pitch. So roll, pitch. If I said that wrong before, sorry. These will be roll. This or this will be pitch, depending on the CG of the wing. Once I get the main wing, it's basically a flying wing. So I'm going to kind of show you where I'm at this point. If you look at iNav, in drone mode, we go to the mixer, and I don't know how much of this is wrong. See, I've got mixer transition 1, 2, 3, 4. They should all go forward. This one won't move just because I haven't got it drilled and tapped in yet. I'm going to be printing support structures for some of the what's going on here. But this is what's going on iNav right now. And if I switch it, it should take me to plane. Okay. Now the servos they're making a noise. I don't know what they're doing. They are transitioning super slow. Now obviously, if you look at iNav, you'll see that my servos I again have mixer transition, and then on stabilize roll, stabilize pitch on the ones that I indicated. You see, it's doing something very weird right now. Hold on. Okay, well, I don't know why it took its time, but it did. And forgive me, I have very little room right here to work with. But when I work it, yeah, that'll pitch the starboard side up. That'll pitch the port side up. But the idea is to have it like ailerons, in a sense. I guess in a sense it is, but see, they're level at this point. So pitch, obviously. Oh, now that one's working. Wasn't working before. Okay. This is supposed to be this way, but like again, I haven't completely and totally tucked everything in yet. You see how it's wanting to move on its own. It's just because it's loose. So it'll pitch up and down, and it'll give me my... Which way was that going? So yeah, so it's going the opposite direction. And the reason for that is so it kind of has this kind of angled swoop pitch control. And then pitch with these engines. I want to try and do this on a wing with no control surfaces. I want the thrusters to be the control surfaces. So the central design of the actual hub or the main fuselage is going to be fairly unique. And then I'll have it set up to where I can put different wings on. The idea is vertical takeoff and landing, which is why I'm going with fairly small batteries at about 3,000 milliamps per. And it's going to be 6L. These are all 6L 70 millimeter motors that I have in here. I think they're 11 or 12 blade. Anyway, my point is
My mixer settings I'm kind of having trouble with. Now I'm going to go to the outputs so you can kind of see what's going on in plane mode. So I'm getting this to where, like, if you look at 3 will go down to 15, and I let it go to center and it's maxed at 2000. I go right with the aileron and I get 15 on 4 and then back to 1000 when I let go to center. So you can kind of see how that's working. I'll try and put the video in there so you can see. Now, the pitch, same thing. So I'm kind of weirded out by this. But if I transition back, it does it really slow for some reason. And I have to get a little bit more clearance in there so it doesn't, so stuff's rolling off the bottom of that motor. Again, don't pay attention to this one. I'm still working on it. So now, for some reason, if you look at number 3 on the servo, it's off. I don't know why any of these, other than being at, because see, 3 should be at 2000 with the rest of them, I assume, if we're all rotating the same direction. So, but in the mixer, I've got 3 as mixer transition, so it should be mixer transition. If you look at my timers, S1, S2, I've got 4 motors and I've got 4 servos. So I am not that familiar with iNav. I'm just not. So if anyone can help me understand this VTOL situation, then, you know, I'll have something here. The fact that I can control the servos that I transition with is kind of nice. It's kind of a new thing, but I don't know, like if you look at the mixer, the servo mixer and the motor mixer, I don't know what it is I'm supposed to be doing. And then someone goes, well, you know, you got to write a CLI program for that. And I'm thinking to myself, how in the world do I do? I don't know anything about the CLI. But all I know is that it functions properly. I can arm it. So it works like it's supposed to, and it'll transition once I get this one attached. And then it switches back again. So we're doing good on the Y4 as far as that goes. The only problem I'm having is my mixer setup. I don't know how to set the mixer setup because these servos, if I transition, they have a lot more movement than that. They have about 270 degrees. So where do you program that in? Where you set those endpoints for that? And what's also causing on the output side, what's causing my forward to go, like when I, let's say, want an aileron to the starboard side, then you would expect a thrust on this side to push it up. I don't get any downward thrust here because this doesn't move. And on iNav, as you can see, it's only 4 moving when it should be 4 and 5, like evenly. So when I you get the idea. You know how ailerons work. So what am I doing, or what do I need to do to get that aileron action that I'm looking for? For one. 2, to get the pitch control I'm looking for, because it seems like I can go back to 15 and then up to 15 on the pitch. So that's where I'm at this. Any suggestions for this would be great. I do not know iNav. I don't know it very well. A lot of people are running the CLI for VTOL. I know I need to slow the transition down when I'm going from lifting to fixed wing forward flight so it doesn't stall out. So I need to know how to adjust those speeds. And I need to know how to get my full aileron control like it's supposed to. Like, when I go, I'm doing it fast, left and right. And you can see it happening in iNav the way it is. But realistically, when I should get, when I bank to the right, like what I'm doing right now is bank right, then the starboard aileron thruster should point down. That way I can kind of limit how much movement is needed for that thrust vectoring. So I'm trying to get away from a system that uses control surfaces on the wings and bringing it all into the centralized area of the control system. So everything is controlled in just right here. So I can change that wing out. I can change out anything I want to on the actual fuselage as far as testing aerodynamics and testing how much lift can I run. I mean, eventually this is going to run a heavier wing. Not a heavier wing, but a larger wing that has enough lift where these 470mm motors can basically be at an idle, and this thing can be controlled by not just iNav, but what was the other one I was trying to use? It was the mission planner on I forget what it's called, but it was mission planner, and the idea is that this could run at a low idle and stay aloft. Plus, it's an experimental system with the EDFs, because everyone's like, drones, EDFs, you can't do it. Or you can, but it has to be small, compact, really lightweight. I have gone through multiple iterations of this. Everything from starting off with a Speedy V405, you know, just a regular old drone controller, now to the wing. The wing didn't have enough power on the ESC because at full throttle to lift before transition, this is pulling 340 amps. So I used a board I got, it's an ADP power distribution board. It has a max current limit of 500 amps. So I was able to actually integrate that into the wing, and I get 2 power connections, one on each side, where I'm going to run 2 3,000 milliamp success batteries. Now the great part about that is it helps to mitigate the heat I was having, because when I had the regular 405 on there and I was running the 4S's before, the amps were too high. I was pulling way too many amps. So the idea was I needed to get the heat down. I needed something that could handle the heat. So I kind of grouped these two together. So there's 2 power distribution boards on this machine. One I'm not using, which is the Speedy B, which I basically just ran 12 volts from the power distribution board I bought, the ADP, from the 12 volt and ground to the battery and ground on the power distribution board for the wing. Doing that gave me the ability to power the board, and the motor signal wires, I only needed just the signal wires to go out to motors 1, 2, 3, and 4 on the power distribution board. Telemetry is another story. I'll deal with that when the time comes, because I've got a telemetry pin on the board, or the ESC, and I have telemetry here. I'm not running ELRS right now. I'm just basically running all these tests with a standard serial bus controller and a fly sky radio. So I want to get a better radio. I want to do ELRS, but I don't honestly know enough about iNav and enough about the controlling of PIDs, things like that, to where ELRS would be beneficial to me. I don't know enough about it yet, so I'm kind of getting into it. So again, you've seen the problems that I have on here. I'm going to try and set this up to where you can kind of see everything that's going on and the video and what's going on. You know, so you can watch them together congruently. So we can basically figure out iNav. I mean, that's what it comes down to for me, is I need to figure out iNav. I've seen a lot of tutorials about VTOL, but this is kind of, it's kind of a unique situation. Because not only going with a Y4, which iNav obviously has a setup for a Y4, the position of the motor for the Y4 in the diagram is farther up here, but the yaw is still the same, so that doesn't matter. I do have clockwise, counterclockwise spinning motors. So, you know, I got that. I've got the drone part down. I mean, that arm, I've got angle mode going. I've got arm it, disarm it. But then I switch it, and I've got half signals. See, now it's even less. I'm wondering if that's just, I don't know. See, now it's less. It's going 11. So, I don't know. Is it the servos? Do I need a different servo? Why does it keep changing? Because I had 15 almost before, and now I don't. Turn angle mode off. Oh, I turned angle mode off, and I've got more. But it's still not. Yeah, so I got to turn angle mode off when I go into that mode. But see, it's still 3 and 4 that want to move independently. So here's right aileron, left aileron, right aileron, left aileron, pitch up, that's going to be that center. Pitch down, it's going to be this one, it'll pitch forward. I mean, you can hear the servo, but like, again, I'm not done building it yet. So, drone mode, though, it seems to work because I've spun it up a little bit and I have moved it around, and it's tried to basically adjust itself. I do need to work on the PID because I don't understand it completely yet. So maybe that's another thing you guys can help me with. This is, you know, it's a learning experience for me. And there is a specific purpose behind this concept, which I will get into at a later date. And you guys will be the first to see it. So please subscribe, grow the channel, get the information out there, because I know that a couple of you geniuses out there are already mulling over what's going on here. One thing I do not know anything about is CLI. And it seems like a lot of people are setting up their VTOLs using CLI. I don't know anything about it. I also I'm concerned about what PID settings I'm going to have to use, considering that these are EDFs. They're going to spin at a higher RPM, so on and so forth. So, without wasting any more time, I will leave you all to it. What is going on? It's resetting. What'd I do? What'd I do? What'd I do? What'd I do? Okay, it's back to drone mode. Okay. And then, see, it goes to plane mode, which is kind of what I want. But, it likes to confuse you by, like, if you look at the screen, it's showing the plane. I'm afraid to lift it. It's showing the plane, showing it move. Basically, these two motors are going to be my ailerons, and then this looks like a Elevon setup almost on this particular plane. I mean, it would have to be. So maybe I got the wrong plane. I don't know. I don't know. We'll leave it in your guys' hands. Just leave a comment. Please subscribe. Get it out there. And let's solve this issue together, because I trust the iNav community and the drone community. You guys are great, and I have learned a lot so far. But most of you are going to say, obviously not enough. But we are going to get there. So again, thank you very much. do what you can. Do what you can. I mean, I'm going to tell you right now, I've got EDFs ranging from 64 millimeters. I've got 70, I've got 28, 40s, and 2800 kilovolt 4S motors. Everything like brand new that I just didn't use when I was deciding how to do this project. And if somebody solves this issue for me, you tell me what you want. You want the 464 millimeter EDFs? Do you want the 4S 2840s, 2800 kilovolt motors? I will send them to you as my gift to you for the gift of your knowledge. All right. I hope everyone has a wonderful day and a wonderful week and a wonderful 20.
All right, if someone will be so kind as to help me in iNav. I have got it set up right now. Okay, so this is airplane mode because I want the two center motors to be pitched. So one will have to be reversed. That'd be too much. There's an idea behind this. These are working okay as far as pitch control for ailerons. Obviously, I gotta get them level. I need to be able to set in points in iNav, and I don't know how. When I switch back to drone mode, it does a slow thing. And now it's like number 4 is not even moving. It's like, see, stop. Now it's not working. I don't know. Someone help me in iNav. Please. I need your help. I need your brains. And I have a bunch of motors and stuff I'll give away. And 4S batteries and stuff. Somebody help me. I gotta go drone, the forward flight. These are my control surfaces. All right, here we are again. I'm gonna boot this thing up, and it's doing something really weird now. So it does this. It's in drone mode. It goes to forward flight mode. 4 is working. And then it slowly transitions back to drone mode on its own. So maybe that's part of the boot sequence. I don't know. But when I try to go this way, back to plane mode, they're moving really slow. Look. This one's moving. That one's moving. Oh, now this one's moving. And then it'll get about halfway, and it does that. And then 4 is now stuck. Won't move at all. I can move these back. What am I doing wrong, man? I need some iNav help. Here we are, everyone. Back again with the abomination of drones. These are 70 millimeter EDFs. Okay, so this is my situation. It does work. When I switch to airplane mode, that's fine. Everything's working like it's supposed to. I'm using my thrust for control surfaces as well as pitch. But number 4 doesn't want to cooperate. When I go to 4, everything rotates back, but like right here, you can see that it's not showing up on iNav. I'm not sure why, but it does transition like it's supposed to, and I can arm it. Oh, wait. I can't. Can I? Okay, so it's arming, it's transitioning, sort of working. Before. All right, we're just gonna check for PID. So I'm gonna hold it. I'm afraid now, so bear with me. I don't know why that servo is doing that. There wasn't enough battery power left. I guess an hour is not long enough for success. But we will keep going on it. I don't know what that twitch was all about, but I gotta work on it. And then I want to get it up in the air. I was almost ready to let it go, and then it ran out of power. So we're getting there. Okay, I've raised the rates on the Expo for the purposes of, on the transmitter to see if that's going to help with the aileron control. I'm going to go low throttle because it seems very aggressive on the aileron control. What was that? Welcome everyone. We saw the last few tests with this design, and I have decided to switch the design up because I had rotating servos at these points, and I wasn't familiar enough with the PIDs on iNav in order to understand how these EDFs are going to react. So I went with a simpler design, which is just a static system without the servos. I don't have to worry about those yet. I'm going to replace everything, put the EDFs here obviously, and then from that point on I'm going to just use static EDFs at this point and try to get a better understanding of the PID configuration necessary to make these function properly before I start putting rotating parts on them. So I've made a huge battery box for this too, because it can lift more than it says it does. So okay, I guess everyone's been waiting for an update. Don't forget though, first to subscribe, because once I hit 100, I am sending out those lipos to one of you lucky subscribers. So with that, I have this going. I have a more respectable arming sequence, slightly lower throttle. I think the 70 millimeters will cut it. Yeah, it doesn't look real clean up here, but again, I'm experimenting with PID output for these motors. So I don't even want to touch the throttle, but I'm gonna. Woo. Okay, that's like almost no throttle and it's just wobbling ready to take off. So I think it'll lift itself, no problem. Suspension test 1 for oscillation, so I can adjust PID. And we're only doing 50% throttle at a minimum. One moment. Definitely have to adjust PID for oscillation. All right, well, we know where we need to go first. It's working, but I've got to get, man, if I had like more expensive components than stuff off of Amazon, this would be a lot more productive. Okay, all of these PID configurations are set by ChatGPT based on all the component information that I inputted. Way better than before. I mean, way better. Way better. All from ChatGPT. And it worked perfect. So to kind of give you a close-up of this thing, it's a mess. I printed everything on an Ender 3 printer. Not too bad. I've bent my components, but it's working. Okay. Well, welcome everyone to my explanation of this monstrosity. So you saw in the shorts videos that it did fly. Everyone's wondering, you know, what's the duration of something like this.
When you're dealing with EDFs, it draws a lot of current, so on and so forth. I had so many issues in the beginning with this particular drone because of, you know, size to weight ratio or thrust to weight ratio, the type of controller I was using, the type of power distribution board, the printer I was using, the constraints of the printer, because I could only afford an Ender 3 off of Amazon. I got it for like 160 bucks. And I'm sure everyone would say that if you had, you know, if your settings were different, you might have better, you know, layer adhesion, or, you know, I don't have an auto bed leveler on it, so it's just, that was also tedious. This was meant to be an experiment because everyone kept saying that the thrust to weight ratio of the aircraft would never get it to be a viable drone solution using EDFs. Now, I've seen people use EDFs to make small drones, like a 54mm one that's fairly small. The motors are really close together, so I can only imagine the expo on that guy's radio. You know, one of the other things I was, you know, contending with was the funding for doing all of this. You know, sticking with Fly Sky radio, it's not a bad radio, but when you're dealing with needing telemetry from the ESCs, which is another thing, I'm just using standard ESCs, nothing that would work with D-Shot. The only thing that I did to kind of solve my problem with heat distribution, because I had such a high current amp draw, full throttle total current draw was, if the ESCs, if the motors were pulling full and the ESCs were at full, 340. So I had a problem with blowing out caps on a Speedy B F405, which I replaced with the wing, the 405 wing. And then there's a standard drone version. But I put the wing on there because I wanted VTOL eventually, but I had to get through this whole PID setting system with EDFs. Now, mechanically, if this was designed a bit more, with a bit more precision, I did this model in like an hour at best, just using solid modeling and Fusion. And it was just, I printed it thick. I mean, it's 4 walls thick, 30% infill. It has a 5,000 milliamp battery in it. And then you've got the weight of each of the motors, the power distribution board, the ESCs, all their wiring, the controller, just about, I mean, all that, the receiver. And I was convinced it would fly. I don't know why. I was just convinced it would fly because this is a heavy drone. And most people contend with power or a thrust to weight ratio when it comes to the drones. So I kind of wanted to explain what was going on here. These are 70mm 6S motors that I'm using. 80 amp ESCs from Skywalker, which I think is a Hobby Wing product. Yes, it is. These are not Fly Sky, Baofun or something like that. Anyway, you can get them on Amazon. And I bought 6S motors and I kind of just put them in the 4S motor 70mm system that I had here. The EDF was 70mm, but the 6S motor fit in there, so I went ahead and ran it. 12 blade fan, so on and so forth. I believe it's a 2040 or something to that effect. I'll try to get the details and put them into the comment, into the description if I miss anything. It is a Speedy B Wing 405. I'm running it serial S-Bus. I have no telemetry going back. I don't have ESCs that would give me good telemetry anyway, I don't think. Because I'm not really familiar with this whole setup. You can see I've bent the living crap out of this thing. Like right here, flipping it over, and it still survived it. At least I believe it still survived it. From its last flight, it looked like it did pretty well. The power distribution board was key to heat distribution and or dissipation, I should say, and along with a thicker gauge wire, obviously for the battery. And it's an ADP board. I forget the brand. I'll have to get the brand and show it to you in like a thumbnail or something. But I'll put it up right about, at one point in this video so you can see what it is, and add it into the description. It can handle a constant current of 500 amps. So that gave me the headroom I needed to not burn anything up, because these wires get significantly hot. As a matter of fact, in one of my later designs, when I start refining this, I plan on integrating just the lowest resistance silver wire or bars that I can directly to the power distribution board through the battery, and then make it to where the battery obviously can be plugged up the way I have it here, where I don't have to take it out of the system. I can just plug it in and charge it. I wish I had a Formlabs, Formlabs L3, the biggest, the big one they got, because then I could really use tougher materials and refine the design, maybe lose a little weight on it without losing any strength. I don't expect them to give me one. I just don't have an extra kidney to sell to get one. And it would probably take that much, to get the setup, because I was quoted 20 grand initially for a setup for, I think, a 3L. And I would love to use their stuff and their different resins and test the resistances when I slam this into something, or if it crashes or fails or whatever. But at this point, I'm just going with what I got. So I may get a Bamboo X1 carbon just to see if I get better layer adhesion. I might get the same result if I could figure out my printer, the Ender 3. I know printers pretty well, but it's just the hot ends. They tend to lose integrity after a while. They tend to not be correct in their, thermistor readings, and you end up getting, and I hate not being able to auto bed level. I just haven't put it on there. It's been a good printer for what it's been through. But basically, when I redesign all this will be integrated into the body itself. And then the wires will be shorter eventually to reduce heat, and using a different type of wire, something with a fairly low resistance, so that I could dissipate the heat even more. Maybe even add some heat dissipation at one point, so that I can, most efficiently do it. And I'm sure the ESCs, if I upgrade to the ones that I saw that were recommended to go with this power distribution board, then they have their own heat dissipation at the top. And so it is something that I could integrate later on, and heat wouldn't be an issue. But when I was using the Speedy Bee F405, not the wing, the regular one, there was a capacitor I had to put on the back, like 1,000 microfarads. And I would spin this thing up using 64 millimeter engines at the time, and that cap would just pop every single time. So I knew I needed something that could handle the power that I was drawing with all these engines. And everyone's like, well, this thing it weighs so much now, because you have this thick model and these huge engines, and the battery's 5,000 milliamps. This is only a 50C battery, by the way, and it still hovered at half throttle with no problem. That was half throttle. I am afraid to bring this to full throttle. I need more stability in the PID, but a lot of that instability could be mechanical in nature, just because of what I'm having to deal with here. So, like, I obviously didn't design a place specifically for my ESCs. I just kind of said, to hell with it, I'm going to hot glue it. That's what hot glue's for, right? So, and like, I did a horrible job doing it too. I was like, I'm done. I just want to fly it. So, I was missing one of my air scoops here. So I printed one, and I was like, it's a Franken-drone, but it's working. And it's hovering, and I was able to get by inputting all of the information I had about the engines, the current draw, the ESCs, the controller, the power distribution board, the battery, the weight, everything. I was able to put that into Chat GPT, and it gave me a suggested PID to start out with, which was more stable than anything else I've ever done. So congrats AI for that one, right? So I'll figure out how to integrate the AI into it later on, so we can like do mission planner stuff. That'd be awesome. But I just kind of wanted to explain what I was doing and what the ultimate goal is. Eventually, I want to utilize VTOL so that I can put this on a wing, or create a wing that uses the 4 motors not only for lift, rotation into forward flight, but also to use the same servo as pitch and roll control for the aircraft. So that all I had to worry about was a decent airfoil. So, yeah, I'm kind of new at the whole controller, PID, you know, FPV scene, that kind of thing. I had a Mavic. There was really no learning curve to it. So realistically, this is all new grounds for me. And it's just, I love it. I just wanted to kind of explain what was really going on with what I was doing and why. And it's merely a concept. I have a lot of people that say they've tried and failed doing this, and I wanted to prove, I mean, this thing's, I could take a lot of weight off of this thing and get even more speed out of it, more stability, I would assume, more flight time. But the next flight's actually going to be a flight test for flight time. I'll try a hover, maybe put it through some paces, and see, you know, what I get. But realistically, it's doing things I thought it would never do, and realistically, it's I don't know if I'm just this got lucky somehow, and I can't repeat it, but I'm doing it, and I'm enjoying it, and I appreciate everyone who is getting involved and subscribing and liking what I'm putting out there. I love the fact that people are able to see this and see that not only one is, I mean, it's possible. Look at this. It's just not, I'm literally throwing shit together out of desperation. And it's just, stuff's broken. My welds, you know, my solder joints look like soft serve. I'm doing my best. But I love the fact that you guys are enjoying the journey with me, because this is going to end up being something really cool, and I hope you all get to enjoy it with me. Thank you very much for subscribing. Please share with your friends and get me more subscribers, because I'm having to giveaway at 100 subscribers for some LiPo batteries, and after that, we'll see what comes up. I have more giveaways, because I'm going to have a lot of extra parts. Thank you all very much for being here. Okay, well, welcome everyone. Alright everyone, we're going to do some more testing. Need to make sure, I need to see what it's doing. I need to trim it.
out most of that in the shot. When it starts sucking up the curtain, it's time to slow down. Okay. Seems to be doing okay so far. When it wants to yaw, though, it seems like the correction on the yaw causes it to drop. So I got to figure out what's causing that, or what to adjust in the PID for that. On the couch this time. It seems to go into a yaw freak out. Let's see if I add a little bit of trim to the yaw. Maybe that'll help. Okay, yaw for sure is definitely a little sloppy. Its responsiveness is not quite what I expected. It's really, really slow on the compensation for the yaw, so I gotta figure that one out. When it starts doing that, excuse my big head. When it starts doing that, I've got to stop it because it tries to get into this yaw overcorrection, and that sends it into a spin. So I got to figure out what's causing that. I was testing out like rapid pitch movements. Let's see if we can't bring it back over here. Alright, on that I was kind of doing some punch tests to see what happened. So we're going to keep going until I kill my battery. out of battery power. And I think I may have... That one seems to be holding up pretty good. Oh, I knocked the motor loose. Yeah, see, that's what it's going to do is beep now that I knocked the motor wire loose. Alright. Well, I haven't obviously killed the battery yet. So... Okay, hold on. I think it's working. Wait, no. Oh, I got 2 motors. I must have unplugged 2 motors. See, I've bent more wires. Told you it was a Franken drone. Oh, there they go. They're good. Hopefully it'll hold up. Let's see if we can kill it. That was it. That looks like it was it. I think that was it for the batteries. Not bad. Looks like we got about... Well, the video's a little over 8 minutes, so... What? 3 or 4 minutes of hover time? Around 50 to 70% throttle when I was punching. Things like that. Yaw is definitely sloppy. So we're going to fix that. Once the yaw is a little bit more punchy, then I think it will smooth out a little bit. Alright everyone, we're going to do some more testing. Need to make sure, I need to see what it's doing. I need to trim it. Going. Hopefully I got most.
Okay, so that was the most nerve-wracking flight I think I've ever had. Everything went pretty well, even after the cat knocked it off of the table today, and I had to hot glue a bunch of stuff back together. But there'll be a full video where I take off 3-4 times, something like that. And this is the first aerial test outside, and it was... Recording? Mm-hmm. Okay. So we're going to try it outside. I have a little bit of a wind, not much, maybe a mile or 2 an hour or so. But I need to see how it acts out here. This may be the last time this drone flies.
Oh, gosh.
Recording?
Mm-hmm.
Recording?
Mm-hmm.
Okay. So we're going to try it outside. I have a little bit of a wind, not much, maybe a mile or 2 an hour or so. But I need to see how it acts out here. This may be the last time this drone flies.
Oh, gosh.
not bad for the first run. Moving slowly in the wind, it's actually doing pretty well. Even with the wind, it's picked up to about 5 miles an hour. And we're gonna go again. Third time's either a charm or the end. I'm trying to do a boost test. So far, so good. The wind's picking up. It's about 5 to 8 miles an hour from the south, which is going from your right to left. Mine's shaking. I got it up there. The battery's going. Okay, we're not going to push it past that. That was a pretty good outdoor test flight for some wind. We're good. All right, doing some more test flights. It might be the last flights. It might be more flights after this. Who knows? We're just taking a risk. Keep recording. We're gonna see how we did that. Kick up any water on anything? Okay, good. I don't know how much battery power is left, so I'm gonna try and stay low. You're gonna make crash. If it crashes, it crashes. That's what this is all for.
right, that was not too many minutes. How many minutes on the recording so far?
2.
Okay, good. Okay, I think what we'll do is check the milliamps and then go for another video later. That's good. Alright, doing some more test flights. It might be the last flights. It might be... That was fun and everything, but this monstrosity is just ridiculous. The lights aren't even controlled by the board. It's controlled by an Arduino that I programmed. I'm just getting the 5 volts from it. I've smashed the hell out of this thing. 4-pound, 6-ounce book with the drone. A little rough, but it's doing it. That's a 4-pound payload, 4-pound, 6-ounce payload with my current configuration. So for those who are curious, the drone comes in at 6 pounds, almost 1 ounce. See, you can tell I've got nothing else on the scale. I tore it out, obviously, before I did anything. And this is the book it lifted. It's actually 4 pounds, 9 ounces. 9.8, if I'm reading that right. Not bad for that hunk of garbage. No, it's actually doing pretty good. Hello, everyone. How are you all? I would just like to say that this drone project has been fun for me. It really has been. I'd like to remind everyone, though, to subscribe that's watching if you would like, because I'm going to be giving away a set of these batteries here. These are nice little roaring top 850 mAh ADC 14.8 volt batteries. And I read it right off of there because I forgot what they were. But I'm glad you like what you see. I'm still experimenting. This whole platform is designed specifically for just getting an idea of the PID and understanding how EDFs are supposed to work and how iNav can control them using filters, things like that. So I'm doing my best. It is a little rugged. That was the whole point. It's been a lot of fun. Thank you all for your views. Please subscribe. So I kind of want to give everyone a close-up of this and kind of show you what has happened since I started doing this. I have flipped it over. I broke pins off in here where I don't even have a battery indicator anymore. I think I'm going to need different fan blades. It's like rubbing on the side when I rev it up. I don't know. What do you guys think? There's like a little bit of rubbing right there. I don't know, it's kind of a mess. So I think I'm gonna have to just get new plastic. I just want to maybe get a quieter blade and go from there. And then eventually when I do the completed project, like the finalized one, it won't be so dirty. Okay, today we're going to be testing the drone with a new battery. We've been running this one right here, this HRB 5000 milliamp 50C battery, 22.2 volt. It's been good, but we got this new 6000 milliamp 100C graphene battery, and we are going to see the difference. Now, for those who are interested, the drone is coming in at, with no battery, 4 pounds, 7.8 ounces. All right, let's get that out of the way. That, tear it out. This battery comes in at 1 pound, 10.4 ounces. The old battery. And the graphene battery comes in at 1 pound, 15.4 ounces. So we'll see the results here soon. This is an indoor test of the 6000 milliamp 100C battery because it's raining. Definitely got a lot more punch. Okay, that was definitely punchier. I think it has a lot to do with the fact that I may have been getting voltage sag out of the other battery. So we'll see how this one flies when it's not raining. Stay tuned. Okay, so this is the 6000 milliamp 100C battery. It's radio on. We're going to give it a test flight and cross our fingers. Get the plug in there. It's a little bit windy from the north, so we'll see what happens. Cross your fingers, everyone. Definitely no motor drag this time. Before it would oscillate. Oh boy, everyone's catching. Wind must be higher up there. What's the clock say?
2 minutes.
You tried to auto-correct yourself right there. But, no, you're off. Alright, so I think what we're going to do at this point, that was at, what was the minutes?
2:30.
2:30. We're going to check milliamps, and then we're going to go again. I'm going to see what I pulled. We'll say, I'll check the time on the video and make sure when I took off, when I landed. And then we'll see how many milliamps I consumed at that point, and we'll go from there. Okay, so this is the 6,000.
here. Oh, geez. Did you see that? Oh, let's bring it back. It literally flipped over. The wind's blowing this way. I'll see you guys straight up. Not bad on recovery.
Okay, so a really quick update. We are going to have to do some cleaning. We got a lot of grass and some other debris in there. I'm going to clean these out, possibly change the fans, try to balance them the best I can. And then I'm going to redo this system here. I'm going to pull this off. I'm going to reprint this. I'm going to fix some wiring problems I have in here, some bent pins and resolder. And then we're going to check the engines themselves to see how they're doing. It's hard to calibrate these ESCs and iNav unless somebody really knows iNav and can help me calibrate. Standard ESCs, they're not D-shot, they're just regular old ESCs. I've got to fix this mess here on the receiver and kind of make everything a little bit cleaner up top and a little bit more protected, and then we're going to move forward. And I may even make some boxes for the ESCs, shorten some wires. That's where we are. Repair time. Okay, just a quick update on the teardown. SpeedyB, I gotta hand it to you. I broke off all those pins right there on this wireless board, and I didn't have a battery indicator, but it still ran. And I'm flipping this thing over left and right. I'm getting my, look at my wiring pins right here for my motor controls. I mean, SpeedyB, you're building them tough. You want to send me a couple more? I'll put them through hell. Put them through the paces. Plus, it's all going down to a 500 amp distribution board, and it's just, soft serve, soldering joints and everything. It's horrible. But I mean, look at the damage here, and it's still kicking. And we got a lot more to tear down, but this is I want to see how these survived, and we'll go from there. She has been reprinted and repaired. She's all good to go. Everything's pinned up. I checked everything. It's all good. Remember to subscribe. Once I hit 100 subs, I'm giving away some fairly expensive LiPo batteries. And then tune in for the Maiden, which will probably be in the next day or two, where I take this outside and fly it really well or crash the living hell out of it. But that's what we're doing all this for, right? I also found the balance marks on the blades, so it shouldn't be as noisy as it typically is. Stay tuned. Remember, subscribe if you want those batteries. That won't be the only giveaway, because I have a whole bunch of EDFs just sitting underneath my desk, needing a home. Find them a home. Subscribe. All right, did some testing. Everything sounds good. Let's check out the harmonics on the motors. A little bit dirty. Oh yeah, I think she's ready.
That was a smooth landing.
Subscribe. Subscribe now.
Hello all. First I'd like to say thank you for all the views that I've been getting on this thing. Thank you for all the likes. Thank you for the subscribers that I have. I appreciate it. Thank you for the compliments and the criticisms. Today we've hit a milestone. I have verified that I got my first hater on YouTube, and I could not be happier. I could not be happier. I'm not going to mention his name. I'm not going to give him the credit for that. But I have my first hater, and I feel like I've accomplished something. That being said, for people who want to know why I'm doing this, because of the consumption rate of the battery and how long you can fly the drone, this isn't the end of the project. There is a final design, and this is going to incorporate VTOL and have a fixed wing design at the end of all of this. This is not me just trying to make a new type of drone. This is a stage in the production of something that I am creating. So yeah, and you can kind of see where I was going with it in previous videos when I had this weird looking carbon fiber airframe that I had designed. Basically designed the joints and Fusion and all this other stuff. You gotta love Fusion 360, right? And I basically got, if I get off track, I apologize. It's the ADHD in me. Basically, when I was designing that, I kind of got ahead of myself when I was thinking, let's start with the VTOL. So I built up the system around the internals of the airframe and experimented with the servo rotation and using the same rotating servos as pitch and roll control. So I had to kind of change gears on that one because a lot of the issue was understanding how flight controllers work with EDF engines. You have a much higher RPM rating. There has to be the PID has to be fine-tuned because the reactions have to be as efficient with open propellers, but they have to happen much faster. And obviously, from what you see here, I don't have, you know, tons of money to be throwing into this stuff, so it's mainly all an Amazon thing. Motors off Amazon, the printer off Amazon. You know, you go as cheap as you can. The controller, SpeedyB, it's inexpensive but not cheap. That's a good controller, that F405 wing. I got to give them credit for that because I flipped this thing over and beat the living hell out of it, and it's still going. You see, I went off on another tangent. My apologies. The point is to understand not only iNav, since I really hadn't done anything with iNav in the past, or SpeedyB's app as well. I hadn't done anything with that either. So it was more of a understanding how to program flight controllers on top of understanding the current demands of the engines. Excuse me, I had an issue with heat, obviously, because we started off with a regular SpeedyB F405 with 64 millimeter EDFs, and I found out very quickly, even though that the ESC rating was there on the stack, there was still too high of a current drain, so it would pop the cap. I mean, it had a 1000 UF cap, you know, microfarad cap on the back of that SpeedyB 405. And the wing gave me the opportunity, and I probably could have done it with the other controller as well, but the wing gave me the opportunity to introduce VTOL, plus it has all the sensors around it that you can plug in for GPS, for, you know, airspeed, for everything. But my system is set up around what I can afford. I'm going to be honest with you, I'm doing this on vet benefits and raising a family. So if you think we make a lot on vet benefits, think again. Okay. Government, everything's to the lowest bidder. So basically, I'm stuck with a serial bus system right here. I'm obviously using a serial controller. I'm not using ELRS, nor do I have an ELRS capable receiver. Using a Skyfly, it's been pretty trustworthy so far. But it's not, you know, very accurate because I'm an old school RC pilot, so I'm kind of used to these things with planes and things like that. I think my very first drone was like a Blade 350, like back in the day before all this FPV came out and everything. So I've been doing this a while, and I thought, okay, I've had jets, I've had planes. I like drones. The technology is intriguing to me as far as the flight controllers and how they're progressing. But the idea behind this project and this stage right here is, can you do it with EDFs and get the proper response from the flight controller? And, you know, I'm going to have to research, or I've actually done a lot of the research in LPF cutoff frequencies for the gyro, for oscillation, which I imagine you get a lot more oscillation and vibration out of these than you would standard propellers. So that has to be fine-tuned. Adding vibration support underneath the mount, so like a TPU platform of some kind, out of the printer to kind of dampen the oscillation. The board is technically isolated. It does have, you know, the rubber grommets between the top and bottom plate, the power distribution board, and the wireless board. And the it's still kind of stiff though, so it's going to pick up a lot of the oscillations, a lot of the vibrations from these engines. And I have noticed, since these are Amazon motors, not going to be the most reliable, I get a little bit of play in the bearings, and that's from unbalanced blades generally pushing the motors pretty hard. So that's basically what I've been dealing with. I get you can kind of hear it. So the bearings are getting to the point where they're shot, so I may just switch them out with new ones, just so I can kind of take that out of the equation for any oscillation or any random movements, so that the PID, once it's finally kind of fine-tuned the way it should be and on a nice TPU platform for vibration, and I've kind of figured out the whole LPF cutoff frequencies and the accelerometer cutoff frequencies, and the Q factor, the unicorn factor, the unicorn Q factor, and the matrix Q factor. So I'm learning all of this stuff. I'm kind of just getting into it, but it is by no means the end of the project or the end product I'm going for. It is it's an experimental platform specifically to understand the language between the EDFs, the ESCs, and the flight controller. And I'm not even using D-Shot yet. I'm just running on standard ESCs. So throttle calibration can sometimes become an issue. One of the motors, because of what I've put it through, maybe drawing more current but getting less RPMs. It's really a balancing act. But I'm very happy with what I've accomplished so far. Just in what I've learned, because that's what it's about. It's about an entire learning experience. It's been great. And I found out that graphene batteries work better than standard lipos. And, you know, I've had people say, you know, 100C is a lot. 6,000 milliamps is a lot. You know, you could run a standard drone forever on that. Well, I mean, I'm glad. I'm glad that if you had that battery, you could run your drones forever. I mean, more power to you, right? But for me, regardless of the runtime, it's about function. It's about how everything reacts. Yeah, I want to know how fast it's going to drain the battery in a hover. Or if I push the throttle to full, if I'm pushing the full 264 amps that I do pull at full throttle. And that's why I had to put a different power distribution board in there, jump it to the Speedy Bees power distribution board, only giving it 12 volts to work with, while using the rest, obviously, here in the PDB. So I didn't know if that was going to work. No one would answer the questions, that I was asking at some of these, retailers that actually sell these. So I'm like, can I bypass that power distribution board? I'm like, well, everything plugs in, so you want everything to be together. So that's not, creating another issue. So all I did was just take a 12 volt output from my board and then put it into the board or the PDB on the Speedy Bee. And then it gave me the 12 volts to operate this and any servos in the future that I might have to operate. The motor controls came directly from the board and then went straight to the pins. All I needed was the signal wires for the motors. That's all I needed. And then the ESCs are obviously wired into the power distribution board. I don't have telemetry coming back to this from the ESC to the Speedy Bee, and I don't have telemetry going from the Speedy Bee to the radio because it's not ELRS. It's S-Bus. That's what I'm running because, to be honest, that's what I could afford. So to anyone who has questions about what's going on here and what I'm doing, like I said, there is an end goal. It is not this. This is a test platform. I'm going to pull these off, add D-Shot ESCs, see how they respond, move, and then I move along. I keep going. Change the motors out for maybe a different style of motor or a different brand, just to see or a different kilovolt rating, just to see what happens. That's the whole point. It's experimentation. You got to do it. I mean, you don't spend, 10 years like the government does with NASA researching or building something and then launch it and it goes and it may or may not work. I kind of like SpaceX's approach. I've got an idea. I'm going to build a prototype. We're going to see what it does, and then we're going to move forward. That's how I like to learn. I mean, that's how I've always learned. That's how I learned to rebuild engines, rebuild computers. I mean, the list goes on. The point is, to answer anyone's questions, this is a test platform. A test platform. Nothing more. It is a stage in the process to get to my end goal, which you will soon see. I'm waiting for my new printer because the Ender 3 is great, but you either got to print it thick and then Dremel off what you don't need, and then, I mean, you guys all know, right? No auto bed leveling, and just everything else. I got a better printer, and it's on the way. So I'm going to get that done. I'm going to get some higher quality motors, some D-Shot ESCs, and then I'm going to redesign the body to make it less heavy than this, because I intentionally printed this one to look absolutely horrendous, and I intentionally printed it thick and heavy. I wanted it to be, because that was the point. Now, if I can operate like I have been with the drone at its current configuration and its current weight, the next iteration should have some significant improvement. So stick around to find out, because that's where I'm going with this. So I hope that answers some questions as to why I'm doing what I'm doing. This is not the end goal. I haven't found the Holy Grail. I have basically just found something. One, it's a passion of mine. It's a test platform. That's all it is. Okay, I'm not trying to put something new out on the market. I don't care if they did it 100 years ago. and it didn't work, so they moved on. I'm doing it because I want to do it, and that's what I love about this kind of hobby. I love being in this country because I can do this stuff. I can learn whatever I need to learn, and you know what? It's just great. It's called freedom. Freedom, baby. I'll put an American flag on this one. Set the bank angle at 90 and pray. But just stay tuned because you'll see what's going on in the future. This is not going to be a quick project. This is going to be, it's going to span some time. That's why I'm doing this. So, you know, be patient. You know, and for the ones who can't be, the ones who have to be haters, and I welcome all of you. I will try to find your constructive criticism with inside your insults, and I will move on. I'll be thankful for them. You're beautiful human beings. You just, you know, you need to get out more. Anyway, love you all. Thanks for those who have subscribed. And remember, if you stuck around this far, that once I do hit 100, I've got some lipos I'm giving away, and they may work for people who use smaller drones. Because they are roaring top 850 milliamp 14.8 volt ADC batteries, which I know a lot of you freestyle pilots love. So at least I believe you do. I don't really know, but I know you might be able to use them. So what the heck, right? Anyway, till next time, see you soon. Hello all. First I'd like to say thank you for all the views that I've been getting on this thing. Thank you for all the... What could be in store, you ask, for the next possible round of tests? Look at that. I want to see how effective these airfoils are when I'm at a 90% bank and I'm at full throttle. They might do nothing. They might have to be bigger, but we're going to find out together.
When the birds are interested.
So I don't know how much it helped, but it was definitely more stable. Definitely.
All right, this is absolute madness, or it's going to actually work properly. Or it'll crash. We'll see what happens. Cross your fingers. That was interesting. Woo! Thanks. The wing didn't come off. That's a good thing. When the birds are interested. That's a good shot. All right, this is absolute madness, or it's going to actually work properly. The wind's blowing it. Oh my God. On the damn birds again. A little bit farther. I almost hit that pole. Oh, the wind's blowing here. It was way too windy for that test, but dang, that was quick.
Welcome, and for those who are still interested in this, I am taking steps to replace the blades. I have ordered them mainly because during construction and repair and things like that, I got maybe a few drops of CA glue in some of the wrong areas, and that caused some imbalance in some of the propellers. I don't have a way to actually balance these blades, so I'm kind of hoping the ones that come to me are pre-balanced. If not, I'm going to try and figure it out. Other than that, I will eventually be replacing this remote with one that will use ELRS, so that I can take advantage of the ELRS on the board and the telemetry and the black box logging and so on and so forth. So things will change. These will go to D-Shot instead of standard ESCs, so I have a little bit more control over what's going on, and the controller knows what the ESCs are doing to stop any kind of sluggishness in motor acceleration, so on and so forth. So stick around.
I felt that go right over my head. Holy let's go try and get some high-speed passing. to keep itself corrected. Stay away from the power lines. There you go. That's good. It bangs. That was a good bang. One of my hot glue methods failed. That's why it was getting kind of banking in the air and I didn't notice it. Let me bring Sally in here.
Tracking subject lost.
Yes, I know. Tracking subject lost. You're okay. Chop some grass. Okay, you down. All right, so what was going on was this. I kept wondering why it was banking like that, like it would swing, and I guess I lost. Yeah, it doesn't like. See, the motors still work, but I lost my attachment point right here. So we're gonna have to fix that. But other than that, everything's working fine, and I don't think there's any motors coming loose so far. But that was interesting trying to fly it at high speed. We'll see how it looks on film. So.
Hello all, I'd like to ask a question to all the drone builders out there who have experience with EDFs or any other kind of motor. Now, where on earth would you go to get bearings for these motors? Because I want to change the bearings in them and kind of freshen up the motors because I'm putting a lot of torque on them. I'm waiting for some new blades to come in. I even got a blade balancer just to make sure everything is, you know, copacetic. I mean, it's supposed to be. So my question is, where do you shop for bearings for these motors? These are obviously all from China, you know, on the ones off of Amazon. I just don't know. I mean, do you go by the size and then pick them out on Amazon? I don't know. How do you do it? Where do you find the bearings for these EDF motors? Okay, so I am waiting for my blades, but I got a balancer, and I was trying it out on one of these blades, and I just couldn't get it to null out. And I'm looking around, and I'm going, you see that wheel right there? Watch, I'll spin it. See it going up and down? How in the shit am I supposed to balance a blade with that kind of quality? Thanks, Amazon. If I wanted to get screwed, I'd just get my wife. Just a friendly reminder that there is a giveaway at 100 subscribers. I am giving away these beautiful Roaring Top 850 milliamp ADC batteries. They are cycled once, twice, maybe 3 times. Flat as a pancake, no bubbling, great condition, brand new basically. I just didn't need them for what my project required. I quickly realized I needed 6S, not 4S. I have 4 of these I'll be giving away at 100 subscribers. At the time that I get that 100 subscribers, if you guys just tell me give away 4 to 4 people, or give away 1 to 4 people, or give away 4 to 1 person, or 2 to 2 people, let me know. We'll do a live giveaway. I'll put your names in a hat, and I will pull your names out of the hat, and whoever the lucky winner is, congratulations. Once we get there, I am pretending we're almost there already. We are almost there already at 86 subscribers, so help me get there. Remember, free stuff. Got a replacement blade balancer from the manufacturer, so you can see the set screw right there. So we're gonna go see if it remembers where it is or if it even notices. I'll try and give it as many spins as I can with a lot of time. Okay, now it's down here. Let's do it again, a little bit slower. Oh, well, it's up here now. Okay. Oh, now it's over here. Let's go the other way. It's over there. How could you balance a blade with this crap? Even new. A replacement right out of the box. Can't wait for my magnetic balancer. Because that's going to kill bearings for sure. Okay, everyone, it finally came in, and we all know what an absolute train wreck this one was. But look, you just blow on this one. Get it spinning, right? And this thing is absolutely totally accurate. I've already done it 2 or 3 times to get 3 registration marks where I can check it. And it is absolutely golden when it comes to balancing. It is so precise, and it's because of that magnetic levitation. It is just perfect. I love it. I don't think I have enough time to get another one in, but you can see where it's just, I did it 3 times and just right back to those same points. So it's just, this is the best way to go. Vibrating a little bit. This is the best way to go, is this magnetic levitation when it comes to balancing EDFs.
All right, new blades. Let's keep our fingers crossed. Hope it didn't mess up PID. They've been balancing. There you go. So. Sounds a little bit better. I don't know if it's going to mess up my PID at all, but. I hope I don't hit my drone. My other drone. Pretty windy up there, I guess. Gonna stay below the wind. I don't know what that spin was all about, but it's not one of the awesome ones, yeah. See if I can just get it to creep forward a little bit. What's the flip over? I think that one motor is just about had it. So I think what we're going to do is change it out and do another one. See, it's much smoother the way it was, but now it's messed up all the PID settings. Yeah, let's see if we can bring Sally down. I'm gonna stop the recording. All right, new blades. Let's keep our fingers crossed.
Okay, so we have the game plan for the drone. Right now we're running, I think it's 3040 or 3060 6S motors in this right now, the ones that are shot with the bearings and everything. Well, these motors never really got used. These 2840 or 3842s, 2800 kilovolts, and these are 2100 and 6S. These are 4S. But I have a 7200 milliamp 4S battery that's ADC. So we're going to run that in here, replace the 6S with the 4S, and see if we get the same performance, if not better, and see, just to see what happens. Because these can handle 4, and the ESCs can handle 4S to 6S. So that's what we're going to do. That's going to be the next one. Might take a little while to swap everything out, but that'll be the next video of this flying on 4S motors with a 7200 milliamp 4S battery. So stay tuned. All right, we have successfully transferred the 6S motors out, which only survived as far as the wiring goes. That's because of the CA glue that was in there. But everything's been transferred out to 4S motors. The only problem is collectively they will pull the full 80 amps from the ESCs at full throttle. The board can handle it because it's a 500 amp board, but I'm pulling 340 amps constant current at full throttle. And a while back it fused my wire extension together, and the wires are too long, so I may let this just drag ass out the back so it can stay cool. But it's going to get hot, so I'm worried about losing a solder joint and then losing power. So we're going to see what happens here really soon, as long as the weather cooperates. It is cool outside, so that'll help. So stay tuned. All right, I couldn't wait. I had to fly a little bit indoors. This is on 4S system right here. A little bit of a rough landing. Not too bad though for a first run. And I'll check the temp on the wire, but we'll get more when it is not raining outside. But I had to throw something out there.
All right, we have the 4S maiden happening right now. This could crash and burn. It could do very well. I don't know. So I have to be very careful, and we're going to see how things work out. One of those motors sounded like it's spooled up like a little late. I'm kind of waiting for traffic to go by. There we go. Whoa, shit! Oh, damn! I think maybe there was a PID malfunction, but that's what glue is for. Let's go take a look. Come on. As soon as I pitched forward, it was done. I don't know what happened, but that wind coming in from the south probably didn't help. Okay, nothing burned. Okay. So it looks like just a few motors came out. The controller's still on, look. I love that speedy bee, man, I'm telling you. All right, that pitched forward way too fast. I should have lowered the expo before we did it. So what we're gonna do is put it back together and do it again. Whoa, shit! Oh, damn!
All right, everyone, the proof is in the platform. Y'all witnessed me slice this thing in half just a few hours ago. That's why I built this platform. You can slice it in half with a barbed wire fence and still be able to fly a couple hours later.
Go ahead. Oh, that seems to have fixed it.
How many times can you slam your drone against the ground because of a malfunctioning ESC?
Oh, here goes. Oh.
We're almost at 100. Subscribe! Stay tuned for the giveaway, everyone. We're almost at 100. We're at 98. And then we'll be giving away. I was going to just do 4 of these. 2 for one person. Because it doesn't make sense just to send you one. Because then, like, if it's dead and you want to swap out, I mean, come on. You guys need more batteries, right? Well, I've got more. I got the 1500 milliamp, 120C, both 14.8 volts. My drone has seen better days. But she will be reprinted and rebuilt. These ESCs are garbage. But anyway, the giveaway is going to be soon. 2 more subs, so don't forget to subscribe. Get us past that 100. And then we will discuss on a live how you want to give these away. Draw your name out of a hat, pick a number, flip a coin. We'll find out. So I did end up finding the problem with this motor. I had that one that was diving out on me, so I kind of took it apart. And you can kind of look up inside here. As you notice, there's a winding here that seems to have a loose end, and I think what it was doing was grounding out as the RPMs would pick up, so it just wasn't wound right at the factory, and I think that was causing that motor to dip after a while. It'd run for a minute and then it would just drop, and you can kind of see how messed up it is in there. So you got to watch the quality of those motors. I'll be looking at those closer next time, that's for sure.
And the bearings didn't fare too horribly. You can kind of see here, they're not totally horrible. They're in decent shape. So check those windings. So here we have the top plate of the Speedy Bee F405 wing APP, and one of the things that I noticed is I had lost my bottom set of header pins here, and I'm kind of wondering if there's a place where you can actually buy replacements for those. They are kind of unique to the board, but it does run the battery indicator, which is on the front here, which doesn't function without it. It also looks like it runs the wireless mode, BL, Wi-Fi, LED strip controller, and switch press to switch effect. Short press to switch effect. So it sounds like it's more LED and Wi-Fi based, but that kind of damage, ripping those off, I may have done some damage to the gyro. So we'll be looking at the second stage of the stack shortly.
First, we started with you, but now I have moved on. Look, everyone, I have some work cut out for me. I got something in the mail. This is a treat. I was afforded, not by Bamboo, they're not affiliated with me whatsoever, but I will plug them in this one because this machine is awesome, and I cannot wait to put it to use. I have tons of different PLAs, PETG, CFs. I've got tons of different hot ends. I've got a Benchy. That is going in the bath tonight after I print it, and that thing's going to be floating around with a little engine on it. I've got all the spools that came with it. I've got tons of assembly to do, but I am super excited. I got extra plates. I'm just floored right now at this. I am ready to get going. Stay tuned for more.
This is nice off of the Ender 3, but this is better off of the X1 Carbon. That's gorgeous. Under 2 hours, this was like 5. Under 2 hours, half the weight, and that was at conservative speeds because I did not want to waste, or I didn't want a chance of this like coming off the bed or having a malfunction. So, but it was still fast. This X1 Carbon is insane and handled, the AMS actually handled this carbon fiber PLA very, very well. I think a lot of people worry about that with the AMS, but I had no issues whatsoever. None. As long as you make sure that thing goes in straight, doesn't rub against the sides the way you cut it, runs perfect. That's beautiful.
And we are Bamboo Lab printing on the X1 Carbon version 9. I love having different colors on this. This is going to be a cherry body compared to the other one. It snapped together real nice. It's going to be all CA glued, but it was just amazing how clean it came out. And I'm just thoroughly impressed. And this is the nacelle housing for one of the motors. You saw the old drone. Poor thing, needs to retire now. Well, we're going to use some pieces off of it, like the power distribution board, but now I'm going ELRS controls, not S-Bus, and I am going to be going with D-Shot ESCs instead of standard ESCs, so we're going to have some major improvements on this version, and we're going to see where it takes us. So stay tuned. It's going to be fun. Subscribe. Okay, this is where we're at right now on the drone. We have some beautifully printed parts. They came out wonderfully. Me experimenting with different materials like carbon fiber and everything else. And I love this right here, this multi-tone Drone power concepts. And that green oxide metal, that's just a beautiful print right there. I'm waiting for parts to come in, and then we're going to start putting everything together. And everything is snapping together beautifully. Everything's fitting together beautifully so far, and it's just going to be cherried out. And it's going to look nice, and I'll be able to tell which way I'm going, which is a plus, because I got confused a couple times. So stay tuned. We're going to have some electronics coming in real soon, and we'll go over them all. Alrighty, we have some new toys to go over, like the Commando 8, which I just got in. I got a new Speedy V F405 wing. I got some iFlight E80 ESCs, 80 amps. I got 4 of those. I got 2.4 gigahertz ELRS controller. That's what this is ELRS. And I got the 915. I wasn't sure if it would work. This is 2.4 and this is 915 and this is 2.4. So I was trying to see which one would work better. The point is, I'm waiting on the motors at this point. Brand new 70 millimeters. Everything is printed up and ready to go. I'm just kind of waiting for those things. And man, I want to put a camera on this thing. I'm hoping to get the run cam in soon, so I can get some onboard footage. I got a GPS for it this time, so we can kind of get some of that GPS hold action, some navigation, so on and so forth. But we are almost ready to rebuild this drone. All right, I tell you what, I'm about to tell you a secret. No glue sticks ever have touched this plate. I'll tell you why. Get hairspray. That's all you need. Take the plate out, clean it off, spray it with a layer of hairspray, let it dry, and it's perfect. It sticks, it's water soluble, leaves your plates looking brand new, even after almost 50 prints so far. Everything still looks great.
Hey, welcome everyone to another episode of I Almost Know What I'm Doing.
And we're back with what we've been doing, which I love so much. I'm working with the new ELRS controller from Commando. It's the Commando 8. I'm running the crap out of that X1 Carbon from Bamboo Labs. It's just awesome. It really is. And I've got some CA and got a new, knocking stuff over. I printed out this new set here to hold all the stuff that I use while I'm building and soldering, and it's working out great. It's beautiful. The drone's coming out looking good. Can't wait for the motors to get here. My wire ready. I even printed out storage containers that look like storage containers. and they come with lids. I'm doing the lid now, and they're stackable. That Bamboo X1 Carbon is amazing. That's all I gotta say. It's rebuild coming soon. Oh my goodness, look what has arrived. All of my motors for the new drone. These are 70 millimeter EDF 6S motors. They are made by Power Fun. They're great. Those are gonna go into the nacelles that I have printed on the X1 Carbon. And Bamboo Labs, they made a great printer, I'm telling you. It's a great printer. We are also running a whole bunch of cool new accessories, including APD, power distribution board. Got the ELRS, we got the new Speedy V F405 wing right in there. And we've got these new iFlight ESCs ready to go. So we are gonna get going here pretty soon on assembly because they have arrived. Okay, so just a quick build portion of the drone regarding the ESC, the iFlight E80 ESC with 100 amp burst. I wanted to make sure that it would stay cool, but be able to be mounted to the drone where I needed it. So I went into Fusion and created this box with some standoffs. And this part with the cap will go towards the back, and we'll slide in, just like so. And then this slotted lid will just slide right in over the top and hold the ESC, hover it off the ground or off of any flat surface and give it an area to cool. The capacitor will be out of the back with a telemetry cable, and now we have an ESC that can be safely mounted on the drone. Maybe this is a question for all of the drone experts that are out there, because I'm obviously not a drone expert. So I'm trying to hook up my iFlight M10 V2 GPS module to this. I've got everything hooked up right, ground to ground, volt to volt, RX to TX, TX to RX, CL to CL, DA to DA. I hope that's correct. Now, this is flashed, the flight controller is flashed with iNav 7.1.0, and I'm not sure if that's right, and that's maybe why it's not working. But when you first turn it on, you notice that GPS is in the UART3. And then you turn on UART3, reboot, and GPS disappears. And then it's nowhere to be found after that. So maybe somebody out there can tell me what I'm doing wrong on the flight controller. Like, what should I flash it with? Where do I get it? How do I set this GPS thing up before I toss it out a window? Thank you.
All right. So today we are going to have fun cramming this into this. But first I'm going to do something that's probably going to give some people a heart attack. Now what I normally do with these is I don't use the tabs or the scoops, because I put it in here. So I'll clip these off and then I'll Dremel them down. I know everyone's like going, no, don't do that, you need those. That's what I mean. I usually put these in place. The plastic's not that expensive to replace. So when you get to a situation where you're like, oh, I want to take that motor out and its blade and put it, you know, on something else, you can still cooperate. Tape, come on. You can still do that. You're not gonna, you can always order these cases or even 3D print it, you know. Gosh, it took like 5 minutes to get that off there. Anyway, all right, so if my calculations are correct, now these will be sealed in place. This is going to be the starboard bow motor, and I am going to see the fit and function. It's looking good so far. Oh, like a virgin on prom night. And I put my securing tabs here, a little bit of CA all the way around, and now we are good to go. Look at that. Look at that, huh? Is that not cool? Alright, so that's how we're going to do the motors. It is countered by some internal fins that they have here to kind of try to counter the yaw a little bit. But it's primarily going to be the opposing motor, which I have, and it's also spinning the opposite direction, so I'll go into the other side. Just like any drone, just with big ass EDF motors to play. This is what finally saved me right here. That APD power distribution board, 500 amps constant current with this thing, which means I can push these motors to their max. They're gonna max out at, I think they're 21 kV, so 66 amps, somewhere around there. So and the ESCs are able to handle, you know those beautiful little iFlights. These are the Blitz E80, and so they'll go 80 amps, 100 bursts. So that'll help And then with using the battery, the battery I'm still using on this is going to be that 6,000 milliamp graphene battery, the LiPo 100C. Same power supply, same engines as I had before, but as you can see, it will all kind of snap together. You know, like so. But it's the same power. It's the same power system as I used before, except the difference is the ESCs on this one are digital, so they're capable of D-Shot, and I can get telemetry back. And I got a card and everything for the new SpeedyB, so it's all ready to go. So I can get telemetry data back from the system. Plus, I'll be running the Commando 8 and the LRS 2.4. So that's going to be a good combination for me, because I went from a Skyfly or Fly Sky radio, and they're not bad, but I wasn't getting the performance or the response or the programmability that I'm going to get out of having, you know, a better controller that's ELRS, more stable range, and you've got, of course, the fact that you've got programmable ESCs and D-Shot and not standard ESC protocols, which was, I think, really holding me back.
So I kind of wanted to just give you a quick walk around. Now, I showed you how the motor pods were put together. We're like on day 2. I showed you how these went together, and they basically just blew into here. And you've got your wires here to connect your motors. And basically what I'm going to do is have the ESC sitting up here. And then I'm going to wire them into the PDB before I put the hat on, which now is programmed. It has a working GPS on there, so that's working just fine. I still have to hook up the ELRS receiver and wire my motors down here on the board. I have a telemetry, and then motors 1, 2, 3, 4, and then I have my 12 volt and my ground here to go to the SpeedyB's power distribution board, because that's how I power it. That's how I get around that overcurrent. This isn't going to push these 4 motors. It's going to be this that's pushing it, and these ESCs, of course, and a 6,000 milliamp 100C graphene battery. But so basically, in this part of the build, I'll try and get some of the soldering in, but I'm sure it's boring for everybody. I'm kind of just showing you the layout of what's going on, and then we're gonna have, you know, ESC here, here, here. I made little boxes for them. I put up a short on that, so that should be available. And this kind of just keeps them suspended, so that they can cool better, because they are aluminum cased on both sides. So I wanted to make sure I could let them cool as it's flying, and still have them safely mounted to the drone. So other than that, I'm just going to run the wires kind of just up to there, and with a little bit of extra, you know, plugs that I have with the 3mm plugs already on them. So after that's all finished, and all the and of course we have the telemetry and the signal and everything. Telemetry, get over here. We've got the telemetry wire, and we've got the signal wire for this. I like it. It's convenient because I don't have to solder it. It has a plug right here, so you can kind of see, if I can zoom in. If I can try and zoom in. Okay, it's better. That plug right there goes right into the bottom of the ESC, so I don't have to solder this here, because I'm still practicing soldering, as you can tell by the power distribution board. But those pins are close. I have enough trouble doing these and putting in the headers on the SpeedyB and stuff like that, so I don't want to do any more soldering than I have to. But basically, this is just held on by some screws, so I can take this off and put headers in there if I want to, header pins. But I'm not going to go that route. I've got a solid core wire that I'm going to use to just kind of go straight in. So it's just really lightweight, not a lot of plastic connectors and things like that. And then we'll go from there. With hooking up the ELRS receiver. I'll try and do some video on basically assembling all of this after this section. So stay with me and we're gonna keep going.
Quick little update on the system that we're building right now for the drone, and I just decided to go ahead and put a fancy little red carbon fiber box for this GPS module, so it's in line with the front of the drone like it's supposed to be, and it's looking stylish with the stickers and that carbon fiber. It's looking beautiful. Okay, assembly has pretty much finished, except for the, any case kind of dressing that I want to put over the top. I do need help though with ELRS, because I've got it set up in iNav as, it's on UART1 and it says serial RX and it's on CRSF under the receiver tab, but I don't know how to bind this to that. And there's I've watched videos where it's like you got to download the firmware and then flash this and then build it and then have your phrase and everything. And I'm like, I have no freaking clue how to do that. So if anyone can leave in the comments like a step-by-step, subscribe, like the video, like the short, do me a favor. Tell me how the hell to work with ELRS. So other than that, everything is all ready to go. So we can get a flight going as soon as I figure this out. Okay, first indoor test of the new drone. Please cross your fingers. I know I am, and the cats are probably going to freak out. Good test. All right. Now next will be outdoor. Let's get a good walk around of it though. Oh, that looks good, doesn't it? All ELRS, B-Shot ESCs. And it sounds a heck of a lot better. What do y'all think? All right, I just wanted everyone to hear what this thing sounded like compared to the other videos of the other version of this drone. I need you to take a listen to it and tell me what you think. Is that not the coolest sound? All the harmonics are balanced. And it's so snappy.
Okay, we're here to test the drone just to see how the function is going to be. It's windy today. I'm going to try and keep it close, low and slow, just to see how everything is, since it's been, this is the first time out, so. Pretty strong, but it's fighting it. Let's see if we can get a speed up to that. The wind is pushing it though. Ooh, it's fighting that wind. It's just for a test. Woo! Oh, signal loss. Oh, what's it doing? What's it doing? Trying to return the hose. So as you can see, I was worried about that ERLS controller, and it would drop loss. See, I don't know what happened. This wire came loose, or that's either before or after the crash, but that's okay because all the rest of everything is fine. I can 3D print everything else. Like I said, I could snap these out and put it all back together. Battery's fine, didn't take any damage. I'll probably reprint it. That motor, yeah, that motor housing's kind of cracked. All of the capacitors and everything are still up and running. Just no loss, just no signal because of this stupid freaking Hobbytown controller that kept losing signal. And I got everything soldered in to the pins. Everything's in there, and I was worried about it because every once in a while, and I probably should have just replaced it before I went up, but that's okay. That's what this is for. The satellites, it acquired the satellites and let me know when it was ready, and then and then it was that catastrophic video. It was a beautiful flight, but when it came back, I could have sworn it was going down over the back of the neighbor's house. Instead, it came flying all the way around, went through the tree and hit the ground, bounced up, landed on the roof, and then it was holding itself, slid down the roof upside down, and then was holding itself against the garage before I shut it down. So, I lost signal, and that's Hobbytown for you. But hey, we'll get a better ELRS receiver. I'll reprint some stuff, and we're gonna do it again because all my electronics are here, and they'll just pop right out. And that was the beauty of this whole design. And with that new Bamboo Labs printer, it is way better, way faster. I can choose different materials. I can do it. I can have this whole thing done in, a day and a half as far as reprinting. I really won't have to solder anything too much because everything's already soldered. So it's just going to be a matter of taking this and, applying it, grafting all the electronics back into the new printed area or the printed body. So, we'll get back at it again, and definitely a different ERS receiver because I'm not exactly sure what that was. Other than the wire either coming loose first or because when I tried to land, as soon as I tried to touch down, that's when I lost signal. And then, so something rattled loose, and then that was it. I had the return to home set, but it was trying to fight wind and stay level, and instead ended up banking around the house like a jet. And but it was worth it, man. That was a hell of a maiden, I'm telling you. Well, back to it again. Won't be too long. We'll be back up and running again. Oh, signal loss. Oh, what's it doing? What's it doing? Trying to return to home. This thing keeps going in and out of telemetry loss recovery. Even in this condition, check this out, man. Everything still works. Even after all that. Even after all that. So I'm just going to reprint everything and transfer everything over. It's going to be, and I'm getting a better receiver because that's just saying telemetry lost, recovered like at random. But you see, everything works. It's perfect. It's a good design. It can fly through a tree, into the ground, and into a roof, and into a garage, all at the same time, or one right after the other consecutively, and still be able to arm and fly. I bet I could fly it right now. All right, I gotta try it. I gotta try it. See, telemetry lost. Okay, EDF drone fans, here it is. This is the odd-looking monster that came off the old drone body. And my battery is safely tucked away in the fireproof bag. All my motors work. Nothing malfunctioned other than the Hobbytown ELRS receiver. The iFlight ESCs all work. The capacitors are in good condition. The SpeedyB Wing F405 APP and the APD distribution board all in good condition. Everything works, including every motor. And now what we're going to do is we are going to reprint this in a matte FDE on the Bamboo Labs X1 carbon, and then we are going to put a better receiver on here that we found from Radio Master, and I hear it's a pretty good one, so we're going to use that Radio Master ELRS receiver this time, and hopefully we won't have that issue anymore, so stay tuned. For all the Star Citizen fans out there, what if we took my drone idea and turned the Cutlass Black into a VTOL aircraft? You want to see it? Subscribe, and we'll get it done. Well, I happened to pull another hater out of the woodwork today. I love it. I want to tell everyone I appreciate you watching my videos, even those with constructive criticism. The man even went as far as to say that I am not a veteran. He's like, your drone idea is never going to take off. You're never going to make a product. I was like, I'm not trying to sell this to anybody. I'm doing it for fun. You tell me if you guys think that this thing flying around friggin' through a tree, all this experimentation and all these different ideas, tell me it's not fun. Subscribe if you believe that it's fun. Just to watch this shit, because I'm going to give you some more stuff. We're doing the Cuddy Black and VTOL. That's going to be coming up next after I get my body reprinted. Hello, all my drone fans, and those who are just interested in watching me fail, and or anyone else interested in this project. I need you, if you're subscribed, to comment on this video. Comment on this short and say I'm in for the drone LiPo battery giveaway. I'll be giving away 2 of these, or 4 of these, and 4 of these. All depends on how many people are going to be in on it. A lot of you have your subs basically hidden, so I can't see who all my subs are and get your names in the drawing. So please, if you like these videos, subscribe to my channel,
Say I'm in the comments, and you will be eligible to win these lipos. Whichever ones you choose. You can have 2 of these, you can have 2 of these. They're great lipos. I just want to do it as an appreciation for everyone who has supported me thus far. Thank you. Make a comment, subscribe, say I'm in. Hey everyone. Welcome to another live.
Hello, everyone. You remember this little mess I got going on here that I had to put back on a body and on the motor. I did print some smaller parts today. And I managed to get this back together. Kind of like the color. It's looking good. That's what I'm talking about, right? I also have a protective cover for this that's going on. And a receiver holder for the Radio Master receiver. And then we got to get all this stuff put in here, but I wanted to do a video on that later about how I assemble all this stuff. Unless you've already seen it, don't care. And we want to go outside, fly it, see what crazy stuff it can do this time. See, just as easy as reprinting the body. Nothing to worry about. But it almost finished. And guess what? He's alive! Alive!
Okay, this question is for all the iNav experts out there. Now, I've got this running on D-Shot 600 right now. But it's a little too fast on the throttle. See how once when I come back down, it just throttles down real hard. I mean, I assume I could try to adjust the throttle expo, but that just, I don't know. It's zippy, but when you let off that throttle down to, I guess it's supposed to go that fast on landing. I'm not sure, because I'm not bringing the throttle up very far. Maybe you guys can tell me. Okay, what we're doing here is a really quick flight test to see if it's actually going to stay where it's supposed to or if it takes off into the ceiling like it did last time. Wow. It said telemetry loss and I didn't lose signal. Good. Well, just like anything, it has to be tested indoors where I have a ceiling that can catch it. Until the maiden. Well, to everyone who is interested in this drone and Star Citizen, we all know the Cuddy Black, right? And we said we were going to turn this into a drone. So I took the footprint of this and I brought it into Fusion along with this model and I broke it apart and I've already started the first print. This is how big it's going to be in comparison. And this is going to be another drone running off of not only 4 70mm EDFs but 6 because I'm making these VTOL. I already set it up. And I'll be running, more than likely, that power distribution board, since I'll have plenty of room, considering the size difference. I mean, this is going to be fun. Just a quick update. We will be doing a maiden soon on this EDF drone, printed on the Bamboo Labs X1 Carbon. But I also wanted to give you an update on the drone for the Cuddy Black. No, it's not this one. It's this one that's in production. It's going to take a little bit of, you know, plastic putty sanding. But what are we going for? Is there a color scheme you guys like in Star Citizen? You want this? You want this the black, the steel? Do you want, I mean, what are you looking for? Because this is going to be a big drone. No, I'm not hoping to just lift it with just these. I already know better. But I did have to scale it up. It's just half of one wing in the front. So, yeah, stick around. Should be fun. So this is where we are so far with the Cuddy Black being printed on the Bamboo Labs X1 Carbon. I know you want to see it, kitty. It's different colors, but it's going to be primered and painted anyway when I'm done and detailed. It's coming out pretty good so far. And I like having the centralized points for the thrusters that are supposed to be there in game. It gives me something to work off of when I'm fitting my scoops for the EDFs that are going to go in there, because those are going to be done by hand. So this whole upper section is going to be open so I can get in and put in electronics, power distribution, set the EDFs, and then get the VTOL going. And we still have to put the cockpit on, which is going to be a live cockpit with lights. And I'm going to find a Star Citizen character, some armor people like. I'm going to print that out, put it in the cockpit. You're going to have lights. It's going to be a fully functioning drone. It's going to be awesome.
Boy, this X1 Carbon's just cranking out the Cutlass Black, just panel by panel. Not everything is glued together because I want to have access points in order to put in everything I need to, but look at the size of this thing. Just massive. This is going to be awesome.
Okay, so this is my situation. It does work. When I switch to airplane, it is working rather well.
That's fine. Everything works as supposed to. I'm using the thrust for control surfaces.
Get ready for the Maiden tomorrow, live if possible. Probably not live because I don't know how to go live mobile. Probably not live, but Maiden tomorrow. Don't miss it. And don't miss out on all the action with the Drake Cutlass Black build.
The maiden of this one, so we'll see what happens. Keep your fingers crossed. If it crashes, it crashes. That's pretty much the whole idea behind this.
is at 50, so maybe I need to raise it. But that was a good flight of V10.